Lesson 9.1, Using Normal Distributions. A normal distribution is modeled by a bell-shaped curve called a normal curve that is symmetric about the mean. So in this picture, the mean is right there in the middle. And notice it's the same on both sides. Now students, when they want to say, I want to be graded on the curve, I've had teachers who actually do that. It's not really that great. Because think about it. You have the C's, and then the B's, and the A's, and then the D's and the F's. So you're not competing against what you're trying to learn. What you are is you're competing against each other. So most of the students would get C's. A few students would get B's, a few would get A's. So maybe I'd have 2 A's, 5 B's, 10 C's, 5 D's, and 2 F's. Now it may be that everybody got over at 90%. Sorry, the last 2 of you still failed. Yeah, grading on the curve isn't great. But this is a normal distribution. It happens in nature, natural, with people all the time, such as SAT scores. Fit on that. Most people get the middle, few people get high, few people get low. So our normal distribution with mean mu, all right, this is a sample mean, and standard deviation has the following properties. All right, the total area under the curve is 1. So this means we're talking about probabilities. 68% of the area is within 1 standard deviation. So the mean is the middle. So that's the area between the mean and 1 standard deviation. And there's the area between the mean and minus 1 standard deviation. So 68% of the data is in the area shaded. 95% of the area is within 2 standard deviations of the mean. And the 99.7 is within 3 standard deviations of the mean. So if you're hit around there, then you're out at the edge. That's usually as far as we go because we're only 0.3% of the data is beyond that, which is a very small amount. You'll probably need to know the numbers there on that graph. Have it for reference for your homework today. A normal distribution has mean and standard deviation. For a randomly selected x value from the distribution, find the probability that we're at mu minus standard deviation. So here's one side, and mu plus 3, so that's right there. So what we're going to do is we're just simply going to add up the areas. So we have 34% plus 34%, so that's this one and that one. Then this one, so that's plus 13.5%. And then that one. Oops, that's not 12. 2.35%. You add those together, you get 0.8385, or 83.85%. So that was all that area. Why don't you try page 470, number 5. Probability that x is less than mu minus a standard deviation. Pause this while you solve it. All right, here's mu minus standard deviation, so it's all that area. So it's the 0.15%, the 2.35%, and the 13.5%, which gives you 16%. All right, the weight of strawberry packages is normally distributed with a mean of 16.8 and a standard deviation of 0.34. If you randomly choose a container, what is the probability it weighs less than 15.5? All right, so our mean is 16.8. 16.18, so that's our mean. And our standard deviation is 0.34. So if I subtract 0.34, I get 15.84. So that was my mean minus a standard deviation. If I subtract another standard deviation, so it'll be the mean minus 2 standard deviations, that's 15.5. And if we wanted to, we could subtract another 0.34, get 15.16. And we could go the other way, 16.18 plus the standard deviation is 16.52. Plus another standard deviation is 16.86. Plus another standard deviation is 17.2. All right, we want the probability that it's less than 15.5. All right, here's the 15.5. So we're going to have that area is less than that. So it'd be 0.15% plus 2.35% is 2.5%, or 0.025. So that's how you do these, is you label the lines by the means, the middle, and then adding standard deviations to the right, subtracting standard deviations to the left. Why don't you pause this and try number 11. When you're done, your answer should be 68%. But the question is, what if what you're trying to measure, find the probability of, is not right on one of those lines? Well, never fear, we have what's called the standard normal distribution. And it's the distribution with mean 0 and a standard deviation of 1. And you get a z-score for a particular x value, and its x value is where to be on the standard normal distribution. And the z-value is nice because it tells you exactly, since the mean is 0, it tells you exactly how many standard deviations it is away from the mean. And that way you can tell if it's, within 1 standard deviation, it's normal. If you're within 2 standard deviations, well, maybe it's a little extraordinary. If you're out at 3 standard deviations, wow, it's very extraordinary. Anyway, this is how you calculate the z-score. The number minus the mean over the standard deviation. All right, so a survey of colleges found the average credit card debt of seniors was $3,450. The debt's normally distributed with a standard deviation of 1,175. Find the probability that the credit card debt, actually we're not actually going to get to the whole probability bit, we're just going to find the z-score. So find the z-score corresponding to an x value of 3,600. All right, so our z-score was x minus the mean over standard deviation. Well, x is 3,600. Our mean is 3,450. Standard deviation is 1175. And when you do that, you get 0.13. So that means it's 0.13 of a standard deviation from the mean, which means it's very close to the mean. So this person's pretty much average. Why don't you try number 33? Find, they gave you the z-score this time of -1.5. So that's getting there to below average. It's 1.5 standard deviations below the mean. What's the mean? So take your formula, fill it in, solve for mean. Pause while you do it. When you're done, you should have gotten 198 for your mean. All right, distributions aren't always normal. They could be bell-shaped-ish, but not quite. In a normal distribution, the mean and the median are essentially equal to each other. In a skewed distribution, they're not equal to each other. If the mean is less than the median, it is skewed left, meaning the mean is to the left of the median. I know if you look at the graph, the bump is to the right, so you'll just kind of have to remember that. If the mean is greater than the median, then it is skewed right, so the mean is to the right of the median, but the bump is on the left. Kind of remember it's backwards. So, is this histogram a normal distribution? Well, it goes whoop. The bump is to the right. The bump is to the right. That means it is not normal, so it's not normal. And it is skewed, and remember it's kind of backwards where the bump is. It's skewed left. The mean is to the left of the median. How about that one? That one's pretty close to the middle, so this one is yes. It's close to a normal distribution. Why don't you try number 23? Pause this really quick while you try it. And your answer should be no, it is skewed right.